Well, hello and good morning. Thank you very much for joining me here in my shop for another, what could be a really interesting round with this radio. So what we're going to be doing today, we're going to explore these spurious signals, sometimes called birdies, unwanted signals that appear to be rife in this radio. And I think what we're also exploring at the same time is an area of my knowledge which is really weak. And so that's what makes this quite exciting for me, because I know this is going to be a voyage of discovery. Now, all these projects are voyages of discovery and learning, and at the end of them I'm always a little better off than I was at the start. So before I get going, a couple things. One, I've changed my video approach here completely, and I'm using my tablet once again, and I made a couple of advances with the tablet, which is why I'm back to it, and I'm abandoning the high definition webcam. And after discovering that while there are high definition webcams, there aren't many computers that can handle a high definition webcam, including mine. So I'm sorry to say I shot like 100 videos struggling with this webcam. No more. So I'm back to my tablet. Great thing about the tablet is, yes, it tends to tip like that. Other than being a little hard to position, which is what I'm doing right now, it's silent, right? It has no fans going in it. There's no sound at all. So while I sit here in the shop, I don't have to listen to those terrible cooling fans. The bane of modern existence, as far as I'm concerned, is the fact that the computer designers reverted to noisy fans instead of just advancing the cooling in some quiet way. That's a real cheap solution. Frankly, all you computer engineers, listen to me now. Get rid of those stinking fans out of those machines. Thank you. Look at this. This thing produces heat. I don't see any fans on it. They got along doing it back then. How come you can't do it now? Anyway, the happy news is I think my videos are going to be done at 720p now instead of the 360. So they should look much better. And I think the frame rate is fine on here too. Wait, so I've learned, hey, listen to me, I'm talking like I know something about video cameras now. So that's basically one of the problems here. You can get a high definition camera that'll take high definition images, but as soon as the light goes a little bit low, it turns the frame rate way down and starts literally snapping individual pictures, and that's when you see that thing going like this. That's what's going on. The camera can't write such a data-rich image fast enough, so it starts slowing down the number of images it's taking. Now I know all this stuff. And why? You know what? After looking at I don't know how many different web resources on this, I found a web page with a small write-up, which is exactly what I needed to read. And that really cleared up everything for me and clued me into the fact that I was not going to have success with the HD webcam. It's a great camera. It produces great images, great lens, everything's great about it, except for that annoying autofocus, which is a known problem for that particular model. But my problem was the computer, and that would be the problem with everybody pretty well. Unless you got a really expensive, very powerful computer, pretty much designed to manage HD. So unfortunately, switching to the tablet means I'm going to be a little busier at this end, because I have to do a little more file work now, moving files around, so I don't like that aspect of it. But anyway, enough talk about all that. I hope you're enjoying a nice clear image. By all means, please make a comment and let me know if you see an improvement or not over what I was doing. I really need the feedback. I did a lot of tests, so I'm pretty convinced, but then I'm looking with my computer, my screen, my stuff, and I don't know that everybody sees everything the way I see it. So okay, so let's get on with the fun here. Now the fun is all these birdies. So the first thing we're going to do, we're going to turn on this radio, we're going to listen to them a little bit and make sure that everybody who's watching this understands, that you who's watching this understand what it is I'm trying to chase down. And this is a phenomenon that I've come across on radios in the past, and I've just kind of shrugged my shoulders and kind of mumbled about alignment. But you know, I don't think that's really the situation. I think there's something more going on, and I think I'm going to get onto it. And thank you all for your comments on the last couple of videos and my plea to help me figure this out. Some great comments and advice has come my way. All of it sounds very realistic and practical, and I'm pretty sure we're going to nail down the cause here. So let's turn this radio on. Let's get this thing going here. Everything looks good. And put the speaker over here. Now, unfortunately, another thing about using the tablet is I have to periodically look at the tablet screen to see what's on it. And if the tablet screen isn't aimed at me like it isn't now, right now I can't see it, I have to move around like this and take a peek and make sure it's make sure all is working. So that's a little bit of a problem with using a tablet. Okay, at the full voltage, and let's hear this thing. Now, you know, the one of the recommendations was short the antenna and see if the birdies go away. So that's the easiest thing of all. We should really try that. Where are they? Where are the birdies? You know what's absent from my shop right now? That big computer. Yeah, that big computer was filling my shop with stuff. I mean, that's quite realistic. Well, I'm not hearing any birdies now. Oh my gosh, maybe this is going to be easier than I thought. Don't have your computer running and you're okay. Let me get a comment about that in a second. Now that's the kind of thing that's been driving me crazy, but I think there's a station right there. Another thing, I did peak the IF on this, and it sounds to me, just like Tom, Hammerhead 88 suggested, I may have over-peaked it, which means I've taken the curve, if you can kind of appreciate this, and instead of it being kind of like that, it's like this. And so as I tune through it, boop, boop, there's just a little spot where you pick stuff up, and then it has this sound, and I can only describe it. It's a little like talking through a tube. It kind of turns it into an echoey sort of thing here. Let's tune through and listen again. I'll pick up a station there. A real station. Hang on, there's one up here. Right there. Well, I don't hear nearly as many birdies as before, but they're still in there, and I have to find the right place to demonstrate what I'm talking about, but not here. See, now that I don't know, is that a coincidence that tone is landing right on top of a signal? Or is that whistle because of the signal there? Let's go another band. See, there's a station there, and right on top of it is this terrible heterodyne. actually Mexico. I'm picking this up with this much antenna. So the radio is very sensitive. It's good. It's very good, I think. But why the tone? Why the tone on top of everything? And it is, as Scotty TR had mentioned, it's very much like tuning a radio with the BFO on, which would suggest there's another signal that's beating against the signal I'm picking up. I can't quite vision it all, but there's definitely something going on here. So let's short that antenna right out. And tune around. Bit of a long lead here for shorting stuff out, eh? It's like just a short antenna is what I'm doing here. Oh, that's no antenna. Usually, when you approach a coil with your finger, you should be detuning it. If it's an oscillator coil, you'll shift the oscillator frequency. This one here does that. But if you're approaching one of the RF coils that's tuned, then all you're doing is detuning it. If you approach it with your finger or something, and the signal gets stronger, I guess two things could be happening. One is you're retuning it into resonance, and it's actually not tuned properly. And you're correcting when you bring your finger up. And the other one is you're just injecting more signal. I think that's what's going on here. Just bringing more signal up and injecting it kind of into the radio. So, because I did a pretty careful job on the alignment. Well, shorting it out didn't have nearly the effect I thought it would. If I get this wire kind of tucked up in here somehow. Yeah, that's not going to make any difference. There we go. Well, it still picks up some hash. Now I think what I'm going to do, now let's go up the other bands. I'm going to turn on my computer in a minute. We'll see if it adds a whole bunch of this stuff to it. Once and for all. Again, the heterodyne. Yeah, there's a radio signal there. So it's just as if there's a beat frequency oscillator operating in here. Not too familiar with the BFO. They're actually audio. Come to think of it, the BFO is actually an audio oscillator, I believe, and maybe they can operate in the IF too. But what you're doing is you're providing a signal to beat the carrier against. You know what? It has to be an RF. It has to be an RF signal. So that suggests, I don't know what it suggests, more than one signal in the oscillator? So that's the next thing I wanted to do anyway, was take a look at the oscillator signal that's reaching the grid. The grid of the mixer tube, or the converter tube, or whatever you want to call it. So, here's the mixer tube. You can tell because it's a complex tube. And let's see how this works on here. Now, the thing about the tablet is there's no focus on it. It has a very tiny lens, and so it's relying on the tininess of the lens to provide sufficient depth of field, so the bulk of what you see is in focus. Doesn't work too good when you get up real close, but I have a solution for that, so we won't worry about it right now. So coming off the plate of this guy here, this is the oscillator here. I studied this for quite a while last night in my office. So this is all oscillator here. Switches, switching in coils against these capacitors. Some of them are adjustable, a couple of them are fixed. And these, of course, were some of the capacitors I was adjusting when I was doing an alignment. And then a little bit of this oscillator circuit is, actually the grid actually extends through both sections of the tube. So when you get this thing oscillating, the grid will be part of the oscillations. It'll present oscillations to the other side of the tube where the mixing and the nonlinear operation is occurring. So I think if we can get my scope lead right onto the plate here, we will see the output of the oscillator without affecting it too much. This is the problem. If I hook up my scope, I may knock the oscillations out of it or change it. But I think we can get on here, and we should see the oscillations. On the other side of this resistor, we should see no oscillations. This side of this little resistor here is brought to ground by one of these big 50 microfarad electrolytic capacitors. So don't think any RF can survive on this line. This line is hard to ground. Should be. If it's not, then we're feeding oscillator signals all over the place here. So we don't want that to happen. So we'll check these things. But hopefully I can put my scope right on the plate of V2. Let's find where the plate of V2 is. V2 is the tube with the cap, the grid cap, and V2, the 6K8 with the grid cap. 6K8. It's so quiet in here now. It's a totally different experience being in here. I like it a lot better than the whizzing of the computer fans. 6K8, which is probably affecting my videos a little bit. Okay, so there's the 6K8. Yeah, they show it as two grids internally connected together. And the plate there is pin number 6. So we want to get our scope on pin number 6 here. Turn on the scope. And we'll use a clip lead to bring the grid out. Now it's this tube here. I haven't poked around this tube very much, actually. So let's see what pin number 6 would be here. Okay, so that's 1, that's 8, 7, 6. So 6 is easy. It's right here. There's the resistor right there. Brown, black, orange, 10K resistor. And this will be carrying the oscillator output. I shouldn't stick my finger on it. The radio's on. Keep the speaker up a little bit, and that'll keep me aware. Or I stick my face right in the radio there. Okay, just adjusting the scope a bit. Where's my scope ground wire? Hey. Hey, who took my nice scope ground wire lead? Where'd it go? Here it is. No, that's not it. Uh-oh. Hey, where'd it go? Okay, I gotta hunt that down.